Next topic is quantum numbers. This is very important topic, very important topic in CBS level as well as in competitive level. First we have to know the definition. The numbers which are used to find the position of electron in an atom is called quantum numbers. That means by using these numbers we can find the position of electron. That means that is present in which orbit, in which shell, in which orbital. That is the meaning of that statement. Therefore, quantum numbers are there. They are principal quantum number, that is represented by small n, azimuthal quantum number, that is represented by small l, magnetic quantum number, that is represented by small m, spin quantum number, that is represented by small s or ms. Now we have to discuss each one. First one, principal quantum number. It was discovered by Niels Bohr. It is denoted by n. The values of n are 1, 2, 3, 4 or k, l, m and so on. And its significance. It explains the size and energy of the orbit, not orbital. Orbit and orbital both are different. So it explains size and energy of the orbit. So these are the points regarding principal quantum number. That's all. Next, azimuthal quantum number. It was discovered by Sommerfeld. It is denoted by L. The values of L is always less than, this is very important point. L value is always less than n value, and the values are 0, 1, 2, 3, so on, n minus 1. Next, significance. It explains about shape of the orbital. It explains about size and energy of the orbit. That means each orbit having certain energy that can be found by using formula. Which formula? En equal to minus 13.6 by n square into z square. By using that formula, we can find energy. This quantum number indicates what? Shape of the orbital. That means every orbital having some shape that can be explained by this quantum number. Next, magnetic quantum number, that is represented by small m. It was discovered by Landé. It is denoted by small m. The values of m depends on L value. This is very important point. In this case, L value is always less than n value, but in this case m value depends on L value, and the values lies between minus L2 plus L including 0. I repeat once again this point. The values of m depends on L value, and these L values lies between minus L2 plus L including 0. Next, it explains about spatial orientation of orbital. I will discuss about this point later. Spatial orientation of orbital. I will discuss about this one later. This is about magnetic quantum number. And next one is spin quantum number. That is, it was discovered by Uhlenbeck and Goudsmit. Uhlenbeck and Goudsmit. It is denoted by S or MS. The values of S are only plus of and minus of. That means S having only two values, plus of and minus of only. Next, it explains about direction of spin of electrons. Direction of spin of electrons. Sometimes electrons revolve in this direction. This is clockwise direction. Sometimes electrons reverse in this direction. This is anti-clockwise direction. When electrons reverse in clockwise direction, then it is having plus of. When electrons reverse anti-clockwise direction, then S value having minus of. Next, there are some more points regarding these four quantum numbers. They are: the number of subshells in a given shell is n. Here I have to discuss these points carefully. Listen carefully these points. See, This is nucleus. These are circular paths, nothing but orbits or shells or energy levels. Now the point is these shells represented by K, L, M, N are 1, 2, 3, 4. Now those shells contains subshells. Subshells are what? 1s, 2s, 2p, 3s, 3p. These are called subshells. 3d, 4s, 4p. These are called subshells. Again, those subshells contains orbitals, and those orbitals contains electrons. I just repeat once again. This is atom. Atom contains nucleus at center. Around nucleus, shells are there. Shells contains subshells. Subshells contains orbitals. Orbitals contains electrons. Now what we have to discuss? How many subshells present in orbit or shell? How many orbitals present in shell? How many electrons present in shell? Those are very, very important points. Before that, we will discuss some more points. They are shell 1, that means first shell, contains only one subshell, that is 1s. Shell 2, that means second shell, it contains only two subshells, they are 2s and 2p. Shell 3, that means third shell, contains three subshells, they are 3s, 3p, 3d. That means here you have to find one point. 2p exists, 1p does not exist. Next, 3d exists, 2d does not exist. Next, 4f exists, 3f does not exist. What are these? These are subshells. Next, fourth shell contains four subshells. First shell contains one subshell, second shell contains two subshells, third shell contains three subshells, fourth shell contains four subshells. From this, what is the statement? The number of subshells in a given shell will be equal to its shell number, nothing but n value. I repeat once again, the number of subshells in a given shell will be equal to n. Next important point, these subshell, 1s subshell, either 1s, 2s, 3s, 4s, any s subshell contain only one orbital. I repeat once again, any s subshell contains only one orbital. Next, any p, nothing but 2p, 3p, 4p, 5p, any p contains three orbitals. Any d, nothing but 3d, 4d, 5d, 6d, any d contains 5 orbitals. Any f, 4f, 5f, 6f, any f contains 7 orbitals. I just repeat once again. S subshell contains only one orbital, P subshell contains 3 orbitals, D subshell contains 5 orbitals, and F subshell contains 7 orbitals. Now, how many orbitals present in a given shell? That is the point. Already we discussed how many subshells present in a given shell. How many subshells? N subshell. That means number of subshells is equal to number shell number. But now we are discussing about what? Number of orbitals. How many orbitals present in a shell? Now consider first shell. In first shell, one subshell, it contains only one orbital. In second shell, two subshells, they are 2s and 2p. But 2s contains one orbital, 2p contains 3 orbitals, total 4 orbitals. See, in third shell contains 3 subshells, they are 3s, 3p, 3d. 3s contains 1 orbital, 3p contains 3 orbitals, 3d contains 5 orbitals, finally 9 orbitals. And the fourth shell contains 4 subshells, they are 4s, 4p, 4d, 4f. The 4s contains 1, 4p contains 3, 4d contains 5, 4f contains 7. What are these? Orbitals. Finally, 16 orbitals. From this, what is the statement? The first shell contains 1, second shell contains 4 orbitals, third shell contains 9 orbitals, fourth shell contains 16. That means the number of orbitals present in a given shell is n square. In case of subshells, n. In case of orbitals, n square. Next, last one regarding electrons. regarding electrons, any orbital, either s orbital, p orbital, d orbital, any orbital can have maximum number of 2 electrons. What I am telling, any orbital can have maximum number of 2 electrons. For example, take first shell, it contains maximum number of 2 electrons because it contains only one orbital. In case of second shell, it contains maximum number of how many electrons? 4 into 2, 8 electrons. In case of third shell, it contains maximum number of how many electrons? 9 into 2, 18 electrons. In case of fourth shell, it contains how many electrons? Maximum number of 16 into 2, 32 electrons. That means, what is the statement here? The maximum number of electrons, present in a given shell is how much? Is 2n square. The number of subshells in a given shell, n. The number of orbitals in a given shell, n square. The maximum number of electrons in a given shell, 2n square. So these are very, very, very important points. See, these are the statements. The number of subshells in a given shell, n. The number of orbitals in a given shell, n square. The maximum number of electrons in a given shell, 2n square. Next, there are some more points regarding quantum numbers. They are, see, for a given L value, the total number of M values is 2L plus 1. This is very, very important point. For a given L value, the total number of M values is how much? 2L plus 1. How can we discuss that point? Suppose, see, if L equal to 1, suppose, if L equal to 1, then total number of M values is how much? 3. How can we say that? By using this formula. If you substitute L value in this one, then we get 3 values. What are they? Minus 1, 0, plus 1. How can we say that they are minus 1, 0, plus 1? Because I discussed already in magnetic quantum number. M values depends on L values and they are from minus L to plus L, including 0. Like that we can say. Next, if L value is 2, then total then M is equal to 5. That means total M value is 5. How can we say that? If you substitute this value in this equation, then we get 5. What are they? Minus 2, minus 1, 0, plus 1, plus 2. Minus 2, minus 1, 0, plus 1, plus 2. This is these are the values of M. Next, some more points. For a given L value, the number of electrons is equal to, for a given L value, this is the point regarding M values. For a given L value, this is the point regarding number of electrons if L value is given. For a given L value, the number of electrons is equal to 2 into 2L plus 1. Suppose if L equal to 1, then number of electrons is how many? 6. How can we say that? Because before discussing this point, we have to know this one. If L is equal to 0, that is S subshell. If L equal to 1, that is P subshell. If L equal to 2, that is D subshell. If L equal to 4, that is F subshell. How can we say that? Because already we discussed this about this one in azimuthal quantum number, that is represented by L. That quantum number indicates what? Shape of the orbital. That means based on L value we can say the shape. So if L is equal to 0, that is S subshell. If L equal to 1, that is P subshell. If L equal to 2, that is D subshell. If L equal to 3, that is F subshell. Next. Now coming to this point, if L equal to 1, then total number of electrons is how much? 6. How can we say that? Because if L equal to 1, that will be P subshell. P subshell contains how many maximum number of orbitals? 3. Each orbital having maximum number of 2 electrons. So 3 into 2, 6. If L equal to, that means what? D subshell. D subshell contains how many orbitals? 5. 5 into 2, 10. So that is the formula. So you have to remember these formulas. 2L plus 1, 2 into 2L plus 1, n square, 2n square. These are very, very important formulas. So this is all about quantum numbers. There are some more points regarding quantum numbers, though I will discuss those points in live class. Thank you.